Hello everyone, my name is Amir Masood and I'm about 30 years old. I'm studying PhD at the University of Southampton in the UK in the field of mechanical engineering. My thesis is generally about rotating machinery and artificial intelligence. I've been tutoring since 2013 in some courses such as mathematics, physics, from elementary to university courses. In addition, uh, I've been tutoring software programming software such as MATLAB and Python in parts of programming, general programming, signal processing, optimization algorithms, and also machine learning techniques. I have experienced classroom teaching and also private teaching since last year due to the situation. I have been tutoring online and remote classroom. And today, uh, in addition to my introduction, I want to solve a physics problem to show my approach and methods, and also my attitude towards the problem and the solution. And because of this, I want to share my screen. So this is a problem. As you see, there is a mass of 15 kilogram, and it is supported by three chords A, B, and C. And this problem wants us to calculate the force in each of these three chords. At first, because this is a static problem and there is no any acceleration and motion, the second law of Newton is generally in this form: mass multiplied by A. Because this is static is 0, and we can conclude that summation of F is equal to 0. So for this chord C, I want to write this equation. This chord is connected to this mass, and this mass has a force due to the gravity acceleration. And if I want this question for these two parts, it could be concluded that the F of chord C is equal to mg. M is this mass and g is the gravity acceleration. So if I want to calculate the forces in chord A and B, and I consider this node here, this is F of A, and this one is F of chord B. And I have another force here that I calculated before. It is mg. I can write this equation for two directions. If I call this direction y and this horizontal direction x, I can break this equation into main direction x and y. In here, in the direction y, I have this force, and these two forces that they could be broken in two direction x and y. So if I broke them in this direction, both of them have element in direction x and y, and according to this triangle I can calculate this angle. I call it alpha. This angle I call it beta. For the alpha, if I draw this line here, and this is 90, the alpha is equal to 19 minus 28, and beta is equal to 19 minus 47. If I calculate them by a calculator, alpha is 62 and beta is 43. So if I break this force in two directions, x and y, in x and y, fa, this is fa y is equal to fa cosine of alpha. This is fa x is equal to fa sine of alpha. And same situation is for b. b by fab x is equal to fab sine of beta, and this one is equal to fab cosine of beta. Now if I write the equation in direction of x, summation of fx is equal to 0. We have just elements of fa and element of fab, because this one is just in y direction. So fax, I consider the x in this direction. It means that fab sine of beta, and fa is the opposite of this direction, opposite of x direction. It is in left direction. Its sign is minus, negative. fa sine of alpha is equal to 0. By some simplification, fa is equal to fa tangent of no tangent, because they are different. Beta. So I have this value, the alpha and beta. It means that I can calculate this term. Now if I write the equations in direction of y, it means that mg, because because of this direction, mg is positive, and two of them, the fay and fby, the opposite of y, they are negative. I have the relation here. It means that plus, instead of fab, I write this term. fab FA sine of alpha sine of beta multiplied by cosine of beta. So plus this term from the mathematics we know that cotangent of beta multiplied by, now if I simplify this term, this is our final equation. I have this value, I have alpha and beta, and so I can calculate FA, and FA could be calculated here, and by this equation FB could be calculated after that. So this is that we solved this equation. We solved this problem. I hope you like it, and also I hope to meet you in real online classroom. Thank you for attention. See you